Hello, everyone. So I'm here to present you a little project that we conduct with our internship right now in Toulouse at Berger-Lovreau. So we try to generate better comments for our method in Java using Moose, the model found in Faro, and any LLM we can come across. So the idea is that when you are using an LLM like ChatGPT, for example, and you passed it some code, you ask it for a comment, and generally what it does is translate the code directly into human language. So it's basically like a plain translation. And as you can see in this example, we don't have any context of what this class is. There is only like a super call. And so it would just say, okay, just call the super constructor. However, we may be able to improve it. If we use it in an IDE, like for example in VS Code, we see that this particular constructor actually has a class, but if we use it with a copilot, it will give us the same answer because it's actually once again using ChatGPT and not grabbing the full context of this method. So the IDE with VS Code, like VS Code that are using those AI tools are actually just a wrapper for some LLM. And it often uses the files that are open to contextualize the prompt. So what you are asking to, the prompt is what you send to the LLM, but the results are really not interesting. So what we are hoping to do is to use a tiny Python server that connects to Faro. So why Python is because we are working with data scientists who are really fan of Python, but it would have been better to use Faro all the way. And this server actually calls Faro that is running a REST API with the Moose model of our code. So we know what is this method in the context of the model. So what are the senders, the implementers, the class, etc., etc. And then we retrieve those information and we send them to the prompt and making the model inference with Ollama, OpenAPI, whatever LLM we want. And for that, we have two strategies to try our approach. We want to use the naive one that is only, okay, generate the comment for this particular code, and we have the improved strategy that we are working on, which is using tons of context data. And we use different LLM like Llama 3, Mixtral, etc. And so in this really tiny example, we can see that our improved method actually grabbed a little bit more of the context. And so it mentioned the edge effect of this particular constructor. That in this particular project, basically, it grabs the domain that is related to software product line, stuff like that. So it use the artifact, which is an attribute of the class. So basically, we have a mention of edge effect, and it explains what is the relation of this constructor to the other entity. And to evaluate our strategy, we are developing a website where we are asking participants to rate our methods. So we can rate them from 0 to 7, so like rejected to excellent. And everything is randomized, so you don't know which strategy is used. For early results, like we rate like 200 comments so far. Oh, no, sorry, 200 comments. And we see that our strategy actually is more likely to be chosen by the developer. And we also saw this correlation that the higher the cyclomatic complexity is, the better the rating would be for our improved strategy. So that's something we need to investigate as well. If you are willing to participate in this kind of study, I leave you the code. I probably will send it to you after. And yeah, you can send us a Java project. We analyze them, and we give you the results. Thank you.